All right. Hello, everybody. Let's get this party started. This topic right here, the Math 128.82, derivatives of the inverse trig functions. I go away from the book on this. Too many forms to memorize. Too easy of problems to do without. And this is true where mathematics is going to be used. We're going to use your mathematics to combine a bunch of topics in one idea. We're going to combine trig. We're going to combine the derivatives. We're going to combine implicit differentiation, We're going to combine some triangles, some pictures, and it's a great process. So there's going to be a lot of twists and turns, but once you figure it out, you'll be much better for it. And I don't know why that line just happened, but this is a great topic. So I go away from the textbook on this because, one, you can't have a note card, and two, these problems are easier without. All right, jot this down. Y equals the inverse sine of x over 3. And we have to find the derivative of it. First thing I do is write that as a regular sine function. So I move the inverse to the other side. There's a couple reasons for that, but mainly I move it to the other side so I can take the derivative of the equation. I know the derivative of x over 3 is just going to be 1/3. Okay? I know the derivative of sine of y would just be sine y, cosine of y times y prime. And therein lies the problem. If I take the derivative of this, I'd have cosine of y times y prime, and that would equal that would equal 1/3. Sorry, I got a new pen at home trying it out, and we're kind of fighting each other. So this isn't really a problem because you can take the derivative cosine of y times y prime. Remember, it's the derivative of the outside times the derivative of the inside. We've already done that. Would equal 1/3. Remember, to find the derivative, you have to get y prime by itself. So you have y prime equals 1/3 divided by the cosine of y, which would be 1/3 secant of y. And remember, the problem started in x's, so it has to end in x's. So y is actually going to be an angle. And once I figure out what that angle is, I can take the secant of it, because that would be the hypotenuse over the adjacent side. Okay, and these will be in x's. So I'd be really close to my answer, 1/3, whatever that is. So I need a triangle to solve that. Remember, sine is the opposite side over the hypotenuse. And I always draw my picture in the first quadrant. So the opposite side would be x. The hypotenuse, the opposite side would be x. The hypotenuse would be y. And we already had problems like this in the last chapter where we would find the missing side. So you can find the square root of 9 minus x squared by using the Pythagorean theorem. Great problem. A little bit of trig, a little bit of a picture in the first quadrant, some trig definition, some implicit differentiation, and you're ready for your final answer. If y is my angle, then remember, all I need for my answer is the hypotenuse, and then all I need is the adjacent side. So it'll be 1/3 times 3 over the square root of 9 minus x squared. Okay? And the 3's will cross off. And this right here would be the derivative, the square root of 9 minus x squared. That's it. That's what y prime would equal. So I'm going to erase this, go through the type version of it, but now you have an idea how we use it. Again, I'm using something new, so it's going to take me a while to get used to it. and you can jot down things. If you feel like that you're still at the train stop, well, that's fine. You'll catch on here pretty quick. So, another way of looking at it, I use this part right here to draw a picture. Okay? I use this to draw a picture. And I got that picture right there because that helps me get my final answer. I'm going to take the derivative of it. Again, the cosine of y times y prime would equal 1/3. All right, so I'm using this over here also to get my derivative. Once you have the derivative, you have to solve for y prime like we always did. And that would give you, 1/3 cosine of y. And 1 over cosine we said would be the same as secant. And remember, y is my angle. So secant of y would equal the hypotenuse over the adjacent side. Really not too bad once you get everything straight. So the first step was to rewrite the problem. That funny line keeps showing up. I don't know why. So the first step was to rewrite the problem. The second step was to draw a picture. Okay? First step, rewrite. I'm just going to leave it. Second step, draw a picture. Third step, implicit differentiation. Fourth step, get y prime by itself. And the fifth step, use your triangle to give you the substitutions. All right? I'll leave those up there for a few minutes so I know everybody's writing them down. Because we're going to do another one, and another one, and another one. This is great. These are great problems. This is mathematics, using all this stuff at once to come up with a solution to a very complex problem. Yes, you can do it. Many classes ahead of you have been able to do it, so I'm very confident you can do it. All right, let's get the other one. Inverse tangent of x squared equals y. Find the derivative. First step, I'm going to rewrite it to get my triangle and to set me up for taking the derivative. I don't know the derivative of the inverse tangent without using the form in your textbook, but again, you won't be able to memorize that, so this is a lot easier, using things we already know. I remember that gives me a picture. The definition of tangent is the opposite side over the adjacent side. What's the adjacent side? Well, 1's silly. So the opposite side is x squared. The adjacent side is 1. So I can get my picture again, drawing it in the first quadrant. And that's what you end up with the hypotenuse. Again, the Pythagorean theorem would be x squared plus 1 squared equals hypotenuse squared. So hypotenuse would just equal the square root of all that, which is x to the 4th plus 1. So that's the second step. I drew my picture. Third step, what's the derivative of tangent? Well, glad you asked, because I think it's secant squared of y times y prime. Again, you've got to apply the chain rule. The derivative of the outside is going to be secant squared times the derivative of the inside, which is going to be y prime. And the derivative of x squared, of course, is 2x. So, I take y prime, I have to solve for it. That's the third step. And then you have 2x over secant squared. And you remember what 1 over secant squared would be? Yeah, it'd be cosine squared. So now, I use my triangle for this substitution. I look at y. The cosine is equal to the adjacent side over the hypotenuse. In this case, I'm going to square that ratio. The adjacent side would be 1. The hypotenuse would be the square root of x to the 4th plus 1. So, I think everybody in the room knows what that would be squared, I would hope. And I need to erase this a little bit. Forgot it came over that far. Give me a minute with my pen I'm trying to work with. There we go. So, I've just made that substitution. And the final answer will be 2x over x to the fourth plus 1. Not bad at all. Like I said, there's quick forms of doing this, but memorizing it, there's too many. This is tried and true. This is something you'll be doing in Calc 2. And this is one thing that former students come back and said they really have used quite a bit. So I really like this. Step number 1, rewrite it. Step number 2, draw your picture. Step number 3, take the derivative. Again, you're using step number 1 for the derivative and for the picture. Step number 4, solve for y prime. And the fifth and final step, use your triangle for your substitutions, and then you get your final answer. All right, look at that. That just looks great. There's nobody else in school that could do stuff like this. All right, here we go. Let's try another one. Yes, we're going to try another one. It's Monday, beginning of a 4-day week. You can handle it. Oh, don't forget, your homework's due at the end of the period. Make sure you hand it back at the end of the period so I can grade it. All right, you remember those evens, 2 through 22 even? Make sure you hand those back at the end of the period. Hand back evens into period. Okay? All right, fantastic. Oh my gosh, the arc secant of 3x the square root. Hopefully remember that arc secant means the inverse secant. And obviously we got a little square root issue here, but we can square both sides. That's not a big deal. And obviously remember arc secant means the inverse secant. So if that means the inverse secant, I can just take that to the other side. What about the angle? It's fine. We can handle y squared as the angle. Again, secant is hypotenuse over the adjacent side. What's the adjacent side going to be? Well, 1. All right? So now my angle is just going to be y squared. We can handle it. Not a big deal. So we have the y squared right here. And we have the hypotenuse is 3x. The adjacent side is 1. And then we have the 9x squared minus 1 as a result of Pythagorean theorem. So that's step number 1. Step number 2, use this to take the derivative. What's the derivative of secant? Well, yeah, it's secant tangent. And the derivative of y squared is 2y y prime. All right? So derivative of secant is secant tangent. This is the derivative of secant. The 2y y prime is the derivative of y squared, and obviously the derivative of 3x is going to be 3. All right, so that's what we took the derivatives of to get that. Secant of an angle is going to be secant tangent. And then you have the 2y y prime. Good. I think we're catching on. We can do it. All right. Now we're going to get y prime by itself. Obviously, you're going to divide everything over. And you're left with this situation. So, now you got to look at your picture. The picture will tell you what secant of y squared equals. That would be the hypotenuse. Well, actually, you can flip that to get cosine. What am I thinking? And you can flip that to get cotangent. So let's flip them first. That comes from your note card, of course. So the 2y we can't flip, but we'll worry about that later. One thing at a time. All right. Let's see. Where'd the 2y go? Let's see. I got cosine of y squared, cotangent of y squared. There should be a y down here also with the 2. So the cosine of y squared is pretty easy. That's going to be 1 over 3x. That's going to be 1 over 3x. The cotangent of y squared, well, that's the adjacent side over the opposite side. That's not too difficult. I'm not making you rationalize any of these. And y, well, according to the original problem, that was equal to the square root of the arc secant of 3x. I didn't say these answers are going to look nice. I just said that's what they're going to be. So the final answer, after you substitute everything in, would be 1 over the arcsecant of 3x times 1 over 2x times 1 over the square root of 9x squared minus 1. And where'd my 3 go? I think it should be a 3 in there somewhere. I'll put it right there. Yes, these can be in any order. It doesn't matter. You don't have to rationalize. You can leave your answer just like that. Because later on, if you find the slopes of the tangent line and things like that, woohoo, it'll get a lot more fun than this. Trust me. All right, so I think the 3 should be in there. Unless somebody figured out where it went. I'd say it'd probably still be in there. Okay. All right. That was fun. And that's a very calculesque problem. Let's try another one. Find the derivative of this expression, y equals x arc cosine the square root of 4x plus 1. Problem be easy all by itself. You can find the derivative of that, and you can find the derivative of this. Remember, we have to use the product rule. F is the first function, and g is the inverse cosine of the square root of 4x plus 1. All right, so we're going to take the derivative of x first. That's pretty easy. That would be 1. So this is f prime. This is g. This whole thing from here to here is g plus f times g prime. All right, now you're going to say, what is g prime? Well, that's where you do some scratch work off to the side. You make the problem, I don't know where those lines come from, but you make the problem, you do scratch work just to find the derivative of the inverse cosine of the square root of 4x plus 1. Once you find this answer, you put it in for this question mark right there. So I've got 3/4 of my answer. I've got the f prime, I got the g, I got the f, and all I need now is the g prime. All right, so I'm going to go off to the side and do some work. This is scratch work, like I said. So here's what the question mark would be. All right, I'm trying to figure this out. Step number 1 is to rewrite it. This is a different y, just so you don't get confused with the problem. And then you have the cosine. Your picture is going to be adjacent over hypotenuse, if you want to look at it that way. So then you left with 1 and 2 times the square root minus x. How'd that work out? Well, you have the square root, of 4x plus 1 all squared plus b squared equals 1. Square that out, and you have 4x plus 1 plus b squared equals 1. So b squared equals negative 4x. So that becomes your, you take the square root of that. Yes, you can have that. That just changes the domain. The domain would be, all x's that are negative. And we can still work it out. Okay, it'll still work out. There won't be any domain issues. Okay. So we've drawn our picture. Nice. We have our equation. We're going to take the derivative of it. And here we go, taking the derivative. The derivative of cosine is negative sine y times y prime 1/2. Whoa, that's a nice derivative. Look at that. 4x plus 1 to negative 1/2 times 4. I wish I could be with you right now having all this fun, but I'm stuck in meetings, so I'm with you in the spirit. How's that? Now you can get y prime by itself, substitute, and you can finish off your answer. All right, I'm getting ready to click it. I'll wait a few minutes. All right, good. So this is where we were at. Solving for y prime, you divide obviously by sine, and that would be cosecant. So the cosecant of y prime would be the hypotenuse over the opposite side. Hey, how'd that turn into, oh, I put the square root of negative 4x instead of 2 minus. I changed this from 2 square root of negative x back to the square root of negative 4x. Why? I don't know, I must have a reason, but probably just keep all the square roots together so I can multiply them inside with each other. Remember, you can multiply innies together. Then you can also multiply outies, but I think you get the idea. Either way, doesn't matter. So when you multiply those together, well, I guess I'm not going to, but this is just the question mark. All I have to do now is put that in the last part of my answer, and I'm done with the problem. All right? So the cosecant of y is just a hypotenuse over the opposite side. And, oh, I think I put that back in there to match the back of the book. I think that's why I did that. Okay. So, the question mark equaled that. All I have to do is put that in right here, and then that would be my final answer. This is going to be a big dog answer. Oh, look at that thing. That's fun. All right. Remember, the first 3 parts of this were easily done just by using the product rule. F prime G plus F G prime. I did scratch work to find G prime off to the side somewhere. Okay, that happens quite a bit once you get in calculus and past. Little scratch work off to the side. Okay, let's try this one. Another product rule. This, if everything goes well on this one, we'll call it quits, but I don't know. We'll see. So, product rule again. Derivative of sine of 2x. Got to use the chain rule and the trig rule. Derivative of sine is cosine, and the derivative of 2x is 2. So this part right here is the derivative of sine, and this part is the derivative of 2x. All right. This part should have a 2 right here. And then I got the sine 2x because this is the g part. Okay, that's g. All this is f prime. This is f. Oh, just f, not f prime. And finally, I have to figure out what is the derivative of the inverse sine of 2x. What is that derivative? And once I do that, I'll be done with the problem. Okay? Yep, scratch work. So, step number 1, rewrite. Step number 2, the picture. And this would be the opposite side over the hypotenuse. So there's the opposite side, and there's the hypotenuse, and again, this is from the Pythagorean theorem. 2x all squared plus b squared equals 1. B squared equals 1 minus 4x squared, and take the square root. So this side should actually be 1 minus 4x squared, shouldn't it? 1 minus 4x squared. Alright, so got that taken care of. Oh, now we're ready for the derivative. The derivative of sine is cosine, derivative of 2x is 2, and the derivative of y is y prime. So, y prime is going to equal 2 times the secant of y. And the secant is going to be the hypotenuse over the adjacent side. So that's going to turn out to be 2 times the square root. Down here should be 1 minus 4x squared. Square root of 1 minus 4x squared. Yeah, it should be 1 minus 4x squared. All right. Now all I have to do is take that and put it back in my answer. Again, this is going to be the square root of 1 minus 4x squared. Oops, sorry. Technical difficulties. 4 x squared. I just put that into my answer, and then I'm done. Slight modification of the solution. 1 minus 4x squared. And don't forget I got 2 here. I got 2 right there also. Okay? And that was a lot of fun. So, I hope you remember EOO means every other odd. You've got plenty of time now in class to get started on it. Not all of them are that difficult. Step number 1, rewrite. Step number 2, draw your picture. It's for a reference on how to substitute later. 3, take the derivative. You're going to use implicit differentiation on that. 4, get y prime by itself. And the 5th step, get the solution in terms of x. Okay? Hey, I want to thank you for being a great crowd. And I look forward to seeing you guys tomorrow and finding out how you did. Until then, have a great day. And don't forget, right now, I want you to hand back and place on my desk all the homework for the evens. Okay? 2 through 22 even. All right. Thank you very much, and have a great day.